Hello friends, welcome back to online school. And then in the previous video we looked at differentiation of sine x from first principles. Remember, we are looking at single angles. And then so we looked at how to differentiate sine x from first principles, and then from that we drew a conclusion that whenever you differentiate sine x, it will give us cos x. And so let's also try to look at the derivative function of cos x. And so assuming that we have our function y equal to cos x, and then so remember we are following the same steps, and then that is you're going to add small changes in y and x respectively. So we shall have y plus change in y equal to cos of x plus change in x, and then after that step we subtract the two equations. So we shall have y plus change in y minus y equal to cos of x plus change in x minus cos x, like that. And then so after subtracting the two equations, we can simplify this to get change in y equal to cos of x plus change in x minus cos x. And so after reaching this step here, we can apply our factor formula, and then so later on we shall divide through by the change in x. But then so when we apply in the factor formula, we shall use this formula here, which is formula number 3. And so we have cosine of alpha minus cosine of beta equal to this expression here. So let's assume our x plus change in x to be alpha and then our x to be beta. So we shall have change in y equal to negative 2 sine of alpha plus beta over 2. But remember, our alpha is x plus change in x, so we shall have x plus change in x plus x divided by 2 sine of x plus change in x minus x this divided by 2. And then so this one here can be simplified further to change in y equal to negative 2 sine. So here we shall have x plus x as 2x plus change in x over 2, then sine of change in x over 2. And then so from this we can divide through by the change in x, so we shall have change in y over change in x, and then even this other side, the whole of this divided by the change in x. And then so after reaching this step here, we can take the limits, and then remember we know that dy dx is equal to the limit of change in y over change in x, but as change in x approaches 0, like that. So we shall have this as the limit as the change in x approaches 0 of negative 2 sine. So this is 2x plus change in x over 2. It is the same as x plus change in x over 2, then sine change in x over 2, the whole of this divided by the change, all of this, we have the whole of this expression here divided by the change in x. Alright, and now here when we are taking the limit, so we happen to find that this is the angle is change in x over 2, and then this is change in x. But then we know that the limit of sine theta over theta as theta approaches 0, it is a 1 in this case. How? Because we know that sine of a small angle in radians is approximately equal to that angle. So it's like when we have sine of theta and then theta is approaching 0, so we shall have theta over theta to give us a 1. So but remember, this is change in x over 2 and this is change in x. So to get the same angle, because what we want it is to be having sine of change in x over 2 over change in x over 2 as we take the limit. So to get such an expression, we are going to say that limit of change in x, limit as change in x approaches 0. So in this expression here, we shall multiply a half in the numerator and then a half in the denominator. So when we multiply through this expression by a half, we shall remain with negative sine of x plus change in x over 2 sine change in x over 2, the whole of this divided by a half change in x. So we shall have the whole of this being divided by I have change in x like that. So we happen to find that when we are taking the limit as change in x approaches 0, this expression here, which is sine of x plus change in x over 2, this part here, it will be a 0. And then for this part here, I shall remain with only negative sine x. And then so when we come to this one here, the limit, now our theta in this case, it is change in x over 2. And then here we have seen that the limit of sine theta over theta, as theta approaches 0, it will give us a 1. But then in this case here, we have our theta as change in x over 2. So we shall have this part here giving us a 1, and then we shall finally get to negative sine of x times 1, which will give us negative sine x. So we shall have our dy dx being equal to negative 1, negative sine x, and then this is the derivative function of y equal to cos x, or our function cos x. So whenever we differentiate the cosine of x, we get negative sine of x. And then so in the next video, let's try to look at how to differentiate functions, trigonometric functions with multiple angles.